Hi. So we're at the point where you've learnt many things and now it's time to test your knowledge. You're going to be able to use equations and graphs to describe motion in a variety of situations. We're going to do a bit for starter first though. What do the 5 letters in SUVAT, SUVAT, represent when we're talking about equations of motion? Can you give me 4 examples of measurements that are scalars? And can you give me 3 examples of measurements that are vectors? Okay. Pause, answer, move on. Done? Excellent. So let's make sure this is working. For the SUVAT, S is displacement. U, initial velocity. V, is final velocity. A is acceleration. And T is time. Give 4 examples of measurements that are scalars. Things that don't really have a direction. Well, we know speed is a scalar. We know mass is a scalar. We know time. And distance. All scalars. Vectors. We've got velocity. We have displacement. And the last one, why not acceleration? Excellent. So let's look at some of the questions. Nice and simple to start off. Select 2 measurements that you need in order to be able to calculate speed. So just write down 1A, either distance, acceleration, temperature, or time. 2 of them. Select which of the followings are units of speed. M, meters, km per h, kms, mph, and h. Which of those are speed? Write down an appropriate measuring instrument for the following distance and time. Distance across a classroom. What would you measure? What would you measure with? Sensible. Time to walk across the classroom. What would you measure with? Or time for a tennis ball to fall to the ground. See, just write the different things for the answer for each one. A dog runs across a park a distance of 40 meters in a time of 5 seconds. Calculate its speed. Simple. Explain why the speed that you calculated is its average speed. A flea jumps off the dog and changes its speed by 1.2 meters per second in a time of 0.8 milliseconds. Calculate its acceleration. Ooh. Change in velocity gives you its change in velocity. It gives you the time. You just need to put those 2 things into the equation. The only tricky thing is, don't forget to convert milliseconds into seconds. Compare the kinetic energy of the dog and the flea. You have to work out the energy for the dog to do that. Explain the difference between a vector and a scalar. We did that in the starter. We gave examples, but we didn't explain the difference. You can do that. Explain how you know that a graph is showing speed against time and not velocity against time. Something about velocity and speed is different. Speed graph will be simpler. Velocity graph has more to it. Runners in a beep test run between 2 markers, steady speed of 4 meters per second in each direction. Sketch a velocity time graph for the beep test. You've seen that already. A runner traveling at a speed of 6 meters per second is passed by a car traveling at 15 meters per second. Calculate the velocity of the car relative to the runner. No, they have to be traveling in the same direction. A bus traveling in the opposite direction passes the runner with a speed of 10 meters per second. Calculate the velocity of the bus relative to the runner. Opposite is important. Here we have a distance time graph for a motorcycle. On the axis we have time in seconds. On the y-axis we have distance in meters. Look at figure 1. That's the graph. Describe the motion of the motorcycle. So what happens? Speeds up, slows down. What is happening? When do those things happen? Talk about in time. Between 0 and 5 seconds, this happens. Between 5 and 15, this happens. Between 15 and 20, and then between 20 and 25. How would you use a graph to calculate the speed between B and C? You know how to do that. Describe how to calculate the speed on curved sections of the graph. Ooh, tricky, but you could do that. Part B, a new graph. This time it's a speed times graph. Look at the graph. It shows the motion of the car. Look at the graph. Describe the motion of the car shown in the graph. Look at that one. It's different. It's a speed time, not a distance time. Same time on the x-axis, different on the y-axis. Can you calculate the acceleration between 20 and 25 seconds? Remember, acceleration, change of velocity. And then calculate the distance traveled between 20 and 25 seconds. Use the equation of motion to show the distance traveled is the same as you've calculated in part A. If you're using a graph to work out how far something's gone, there we are under the graph. A student decides to get off a London Underground train at one station and race it overland to the next station. The train travels a distance of 0.24 miles. They both arrive at the station 1 minute, 20 seconds later. Calculate the average speed of the train in meters per second and in miles per hour. Tricky. There are 1,609 meters in a mile. Suggest and explain how it might be possible for the student and the train to have the same acceleration. Think back to the starter. What was a vector? The mass of the train is 60,000 kilograms. Use the average speed of the train to estimate how fast the runner would need to travel to have the same kinetic energy. And make a comment. And that's it. Just a chance to practice some of the things you've learned. So, answer all of the questions. There's definitely enough time for you to be able to answer all of the questions. Write down your answers, send it to your teacher, and I'll put the answers to this up in a few days' time. Okay, good luck. Love you. Bye.